Hey, welcome to RAR Math. Today I'm doing a series of videos on systems of equations, and in this video I'm going to graph two equations. I have some vocabulary I'm going to add at the end, just so that we can have a complete lesson. So remember, f of x is the same as y. Y equals 3x plus 4. They're the same thing. When I graph, I start with the y-intercept. So if x is 0, then y is 4. So I start at 0, 4. My slope in this equation is 3, but what I'm going to do is I'm going to say 3 over 1. Up 3 over 1. But I need more points. I could use a ruler and graph, but I probably would get off course pretty quickly. So I'm going to say negative 3 over negative 1. That's how I backtrack. Both signs need to change. Negative 3, negative 1, negative 3, negative 1. I like to go all the way across because one of those 6 points is going to be my solution. If I only had 2, I could have easily gone like this, and you can see how I would have some false answers in there if I didn't have a precise line. So to me, the security of getting all those points in makes it worth it to me. Okay, my next line, this is the equivalent of y equals x. This for some reason ends up being a really hard line to graph for many students. It's not horizontal or vertical because you have two variables. If you have two variables, your line is slanty. You should think of this as y equals 1 times x plus 0. So you see that your vertical intercept is 0, 0, and your slope is 1 over 1. 1 over 1. Now we're moving away from this line and we're trying to intersect it. So again, negative 1 over negative 1, that's how we backtrack. Here's our point of intersection. I think I have enough to graph my line, and so here goes nothing. So my point of intersection is negative 2, negative 2. Now I can check it. 3 times negative 2 is negative 6, plus 4 is negative 2. Y equals x. Y equals x. These two lines are independent. Independent means that they are two distinct lines, and they are. This system is consistent. Consistent means there is at least one solution. Anytime you have an intersection point or the same line, it's considered consistent. If you have parallel lines, it is inconsistent because parallel lines do not have a solution. Okay, when I'm graphing x minus y equals negative 4, I like to use the intercepts. I like saying when x equals 0, then negative y equals negative 4, or y equals a positive 4 and graphing 4. If y equals 0, then x equals negative 4, and I have negative 4. This is one of the few times in which I just use 2 points to graph the line. Sometimes I will figure out the slope and pull it out, but there is that line. Okay. If you don't like doing the intercepts, if you're sitting there going, oh, please no, it's not hard to take x minus y equals negative 4, subtract that x over, so that negative y equals negative x minus 4, multiply through by a negative 1, so that y is equal to x plus 4. Plus 4, slope of 1. Very easy process that you can do pretty quickly. It's 2 steps. Subtract the x over, divide. This is already in slope-intercept form. My intercept is negative 5, 1, 2, 3, 4, 5. My slope is negative 2 over 1. If I go negative 2 over 1, I'm going away from the other line, so I do a positive 2 over a negative 1. Positive 2, negative 1, positive 2, negative 1. There's my point of intersection. And then I have enough points to comfortably graph my line. So if I graph my line, my point of intersection is negative 3, 1. I like to check. Is negative 3 minus 1 negative 4? Yes. Negative 2 times negative 3 is 6. 6 minus 5 is 1. That also checks out. I am confident I have the right answer. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you in the next video. Thanks.